Hi dear friends, good morning to all. This is Bhavsar Sonone, Assistant Professor, Department of Chemistry, Gokul Education Society's Arts, Commerce and Science College, Jawar, District Palghar. Dear friends, in the previous part of this lecture series, we discussed about the particular type of process called as fission process, how the fission of nucleus take place, what are the different materials which undergo fission and producing a large amount of energy, and in that we discussed about the two types of the materials or the substances called as fissile material and the fertile materials. At the same time, we discussed about the different factors responsible for the fission process called as multiplication factor K, and another one is called as critical mass or the critical size of the fissionable material. At the same time, the whatever amount of energy liberated during the fission process is called as the fission energy. So all these things we discussed in the previous part. Today, dear friends, in this part of the video, we are going to discuss about the particular device in which we are able to convert here in which we are able to obtain the energy by means of fission process in a controlled manner called as nuclear reactor. But before this, if you are remember about the last lecture or the last video, then we discussed about this process called as the fission process, because today in this lecture this is one of the most important process which is used to convert this nuclear energy into electrical energy. How we can convert this nuclear energy into the electrical energy, and definitely in order to obtain the nuclear energy, this process is very important called as fission process. So dear friends, in the previous part we already discussed about the fission process. What is fission process? So whatever fast moving neutrons, these are slow down, then these slow neutrons are responsible for the fission of other heavy nuclei, and this leads to the chain reaction. So definitely what is the fission process that we can discuss here. But these fast neutrons, whenever converted into slow neutron, then these slow neutrons are responsible for the fission of another heavy nuclei, and definitely it leads to the chain reaction. Dear friends, here this slide indicates the nuclear fission, means the conversion of this heavy nucleus into, that is nothing, the smaller nuclei which are having nearly same size or the same mass, and this, whenever this heavy nucleus is bombarded with this neutron, slow neutron, then it will try to break up into more than two parts or more than one part, and definitely it leads to the formation of smaller nuclei with the formation of another number or the new number of neutrons here. So this process is called as a fission process, and the whatever material which undergoes fission, this material is called as the fissile material. Definitely based upon the process, these material substances are divided into two types that we can discuss here. But this is the just the recapitulation part of the previous part. Dear friends, this is one of the example that indicates the conversion of heavy nuclei into lighter nuclei. So this is the uranium 235 having the mass 235 and the atomic number 92. So whenever it is bombarded with the slow neutron, then this uranium get converted into two nuclei. One is the barium 139 and another one is the krypton 95. So these are the lighter nuclei as compared to the uranium 235. But whenever this uranium 235 get converted into these two lighter nuclei, during this conversion, during this formation of this lighter nuclei, there is a liberation of large amount of energy, nearly 200 million electron volt, and at the same time there is a formation or the liberation of these neutron, but these are the fast moving neutron, and whenever these neutrons are again converted into slow neutron, Again, it is responsible for the same process, that is nothing but fission process. So here today, dear friends, today in this part of the video, the important part of the discussion is the device which is called as a nuclear reactor. So what is nuclear reactor? Why we are going to discuss this nuclear reactor or this device in this part? This is also one of the important thing. But this nuclear device is the nuclear reactor is the device in which nuclear energy due to fission process or the nuclear fission is obtained in the controlled manner. And definitely this reactor requires some essential part. This nuclear reactor requires some essential part, and what are these parts? So here today in this part of the video we are going to discuss about the nuclear reactor and the essential parts of this nuclear reactor, without which definitely this nuclear reactor will not be able to work, because in this device we are going to obtain the nuclear energy. Later this nuclear energy can be converted into electrical energy or the other form of the energy, but this nuclear energy is obtained due to the process, and this process is called as nuclear fission. Nuclear fission means the conversion of heavy nucleus into lighter nucleus whenever it is bombarded by slow neutrons, definitely, and with the liberation of large amount of energy. But this nuclear fission should be in controlled manner. It is very important. This nuclear fission should be in the controlled manner, otherwise it will be very dangerous. That's why we have to carry out this nuclear fission in the nuclear reactor in the controlled manner, and that's why it requires some essential parts. The first part or the component of the nuclear reactor is called as neutron source. So here, because here simple conversion of heavy nucleus into lighter nucleus whenever it is bombarded by slow neutron, so we will require the source of neutron, and this slow neutron with the energy of around 0.025 million electron volts are called as thermal neutron. So these slow neutrons with the energy of 0.025 million electron volt are called as thermal neutrons, and these are used for the fission process. So this number of neutron, how many number of neutrons are available or these are emitted from the particular source, then this number of neutrons emitted per second from the surface area of 1 centimeter square is called as the neutron flux. So number of neutrons emitted per second from the surface area of 1 centimeter square, then that number of neutrons are called as the neutron flux. Again, the second important component of this nuclear reactor is called as the nuclear fuel. This is again one of the important. So the first neutron source of neutron is definitely important component, but these neutrons are bombarded on the material, and that material is called as the nuclear fuel. Definitely based upon the process, these nuclear fuels are divided into two types that we will discuss here. So what is this nuclear fuel? Nuclear fuel is the target material on which the neutrons are bombarded. So this is the target material on which the neutrons are bombarded, and that target is called as the nuclear fuel. So this nuclear fuel is either uranium-235, uranium-233, uranium-239. These undergo fission directly. It's very important. This uranium-235, uranium-233 and uranium-239, these materials undergo fission directly and producing large amount of energy whenever it is bombarded by slow neutrons, and that's why these materials are called as the fissile material. I hope you can understand this very easily, because all these things we discussed in the previous part, but this is the one type of the material or the nuclear fuel which undergoes fission directly, producing large amount of energy, and that's why these are called as the fissile material. Another type of the materials, these again important one, called as uranium-233, is obtained from thorium-232. This uranium-233, actually uranium is the fissile material which undergoes fission directly, but it is obtained from what? It is obtained from thorium-232, and plutonium-239 is obtained from uranium-238. Hence, This thorium 232 and uranium 238 are called as the fertile material. Are called as the fertile material, and these that's why here you can say that these materials undergo fission directly, and in this type of the material initially get converted into another one, and later on it get undergo fission. So based upon this, there are two types of the nuclear fuels. First one is called as the fissile material. What is this fissile material? Substances which can undergo fission directly with the slow neutrons and liberating large amount of energy are called as the fissile material. So already we discussed about this, I think you can understand. So the material or the substances which undergo fission directly, so here it will undergo fission, it will undergo broken down into smaller one or the smaller nuclei in one step whenever it is treated with the slow neutrons, and it is liberating large amount of energy. And these are the three materials which undergo fission directly, producing large amount of energy or the liberating large amount of energy. That's why these materials are called as the fissile material. So this is the one type of the nuclear fuel that can be used in the nuclear reactor to produce nuclear energy. So this is the one example that we discussed in the previous slide, that uranium 235 get converted to barium 139 and krypton 95. So this is one example of the nuclear fuel which can be used in the nuclear reactor to obtain the nuclear energy in the controlled manner. Dear friends, based upon the fission process, another type of the material are called as the fertile material. So what is the fertile material? The material which though itself non-feasible, it is not feasible means it will not undergo fission directly. So though it is non-feasible, but it can be converted into feasible material. It's very important. So it can be converted to that material which can undergo fission directly by the reaction with the neutron, and that materials are called as the fertile material. And the example is nothing but uranium 238 and the thorium 239, because these materials cannot undergo fission directly. Initially these materials are converted into another nuclei, and then that nuclei undergoes fission to produce large amount of energy. That's why these materials are called as the fertile material. So these are the example. Here you can see here uranium 233 is the fissile material which undergo fission directly, but thorium 232 get converted into uranium, but this thorium does not undergo fission directly. That's why thorium 232 is called as fertile material. And here you can see uranium 238 get converted to plutonium. This plutonium can undergo fission directly, but not uranium 238. So this uranium is not able to produce energy. Actually plutonium is able to produce energy. That's why uranium get converted to plutonium, and then we will get energy. That's why this uranium 238 is called as fertile material. So here it's very simple to discuss the fertile material and the fissile material. The third important component of the nuclear reactor is called as the core. So what is the core? Actually this is one of the important part which is present in the center of the reactor. So this is the central part of the reactor in which the nuclear fuel is placed or the nuclear material is placed. So that part is called as the core. So this is the inside central part of the nuclear reactor in which nuclear fuel material is placed, and that part is called as the core. The next component is called as the moderator. Moderator, definitely the words itself indicates that it is involving in somewhat processes. So what is this moderator? Let me adjust this first. This moderator is having one of the important function in the nuclear reactor. Actually the fusion of uranium is because of the slow neutron. Means for the nuclear fusion we are requiring this component, that is slow neutrons. If the slow neutrons are not there, definitely the fusion of the nucleus, heavy nucleus, is not possible, and we will not get the nuclear energy. So in order to obtain the nuclear energy, this target material or the nuclear fuel must be bombarded by slow neutrons, and these neutrons released in the Fusion reactions, these are the fast neutrons. Actually, we don't want fast neutrons, we are requiring the slow neutron. And in order to convert these fast neutrons which are released in the process of nuclear fission, these fast neutrons should be converted into slow neutron for the nuclear fission, and these fast neutrons are converted into slow neutron with the help of material, with the help of component, and that component is called as a moderator. So whatever substances or the materials which are used to convert fast neutrons into slow neutrons, that materials, that substances are called as the moderator. And generally, in order to convert in order to convert these fast neutrons into slow neutrons, the different types of the moderators like heavy water or ordinary water or carbon in the form of graphite rods can be used. So the function of moderator only is that the whatever fast neutrons obtained in the nuclear fission, that can be converted into slow neutron. And the example of these moderators are nothing but heavy or the ordinary water or the carbon in the form of graphites. Next one is the control rods. Control rods, these are also important because the neutrons are emitted in the fission process, and during the nuclear fission, what happens actually, the large number of the neutrons are emitted and their number increases rapidly, and sometimes it can be very dangerous. If the number of neutrons increases rapidly, then this number of neutrons will be responsible for the nuclear fission, and definitely this rate of nuclear fission process will go on increasing, and it will produce large amount of energy, and definitely it can be a dangerous process. So here, in order to control this excess neutrons, some rods of alloy, particularly cadmium steel alloy or the boron steel alloy, are used, and that rods of cadmium steel alloy or the boron steel alloy are called as the control rods. The main function of these rods, control rod, is these are responsible to absorb the excess number of neutrons which are released, which are liberated in the process of nuclear fission, and hence these are responsible to bring their number within the control of nuclear fission. So here the number of neutrons should not be increased rapidly. So in order to control the number of neutrons in the nuclear fission, the rods of alloys are used, and these rods are called as the control rods. Again, sometimes what happens during the nuclear fission, sometimes the temperature of the nuclear reactor, particularly core, increases too rapidly, and in order to control the temperature, some substances like heavy water or only the water, liquid helium or the carbon dioxide are used to remove the heat generated in the core part of the reactor, and this heat generated in the core part of the reactor is removed with the help of substances called as the coolants. So these coolants are normal water, heavy water means deuterated water, or the liquid helium or the carbon dioxide. So these are the examples of coolant. Definitely it is used to control the temperature of the core of the nuclear reactor. Next one is neutron reflector. What is the purpose of this neutron reflector? In order to prevent the escape of neutron from the surface of the fuel, from the surface of the nuclear fuel, the core of the nuclear reactor is surrounded by the particular layer, and the layer of substance particularly, and that substance is working as a reflector. So here, in order to prevent the escape of neutron from the surface of nuclear fuel, this core is surrounded by the layer of particular substance, and that substances are called as the nuclear reflectors. The purpose of this nuclear reflector just to prevent the escape of neutron out of the core in which the nuclear fuel is placed. Another thing is that another component of this nuclear reactor is called as a shielding. Actually, shielding, this is the protective component, and in order to prevent the leakage of radiation, the reactor is protected or shielded with the layers of thick sheets of lead or the thick lead sheets, and in order to prevent the leakage of radiation from the nuclear reactor, the whatever sheets, particular thick sheets of lead are used, and that thick sheets of lead are called like the shielding material or the shielding covering. The purpose of this shielding is to prevent the leakage of radiation out of the nuclear reactor, because once these radiations are become these radiations leaked, then it will be a very dangerous for the human being as well as for the living organism. That's why it should be protected, and the leakage of this radiation should be avoided, and that for that purpose the particular layer of the lead sheets are used, and these are called as the shielding. So dear friends, in this part of the video we try to discuss the various important component of this nuclear reactor. Nuclear reactor, the device in which the nuclear energy is obtained from the fusion of the nuclear fuel or the nuclear material in the controlled manner. And this nuclear reactor or this device requires essential component without which we will not be able to obtain the nuclear energy in controlled manner. And these component we discussed in this part of the video. In the next part of the video we will discuss their arrangement, their construction in order to obtain the nuclear reactor, which is also called as the power reactor. In the nuclear reactor we are trying to get the nuclear energy, but whenever this nuclear energy simultaneously converted to electrical energy, it will be called as the power reactor. So definitely this power reactor will also require the same component that we will discuss in the next part of the video. So I hope you understood this very well. In case any doubt, you can ask, you can contact. Thank you very much.